Okay, today's going to be a quick overview, and it's going to be, you notice when we melee in the demo, there's no clipping. The weapon is always in front of the enemy or any wall or anything like that. But if we go out of the player, it's actually clipping through. Even if we turn on the collision, you can see the player collider is smaller than the weapon sticks out, and yet when we go into the first person view, it stays in front. So some of you may know what's happening here already, but we're going to overview. Really, it's all goes, there's this custom material function that you can make that, using the world position offset of a material, sets the material to always be in front, regardless of if the weapon is clipping through something. And then a side benefit of that is that under the settings, you can actually independently adjust the field of view. I have it set in here actually, of the weapon separate from the camera. So for example, when I zoom in, I'm actually increasing the field of view of the weapon differently than the camera itself. So that way the weapon looks almost purely isometric. You can really tell this with like the scope. If I just zoomed in as much as I did with the camera, it wouldn't be, the scope wouldn't be as flat as it is here. So that's one of the benefits. And the scope remains the same. See how I'm zooming in and out with the player camera, but the scope is kind of remaining at the same field of view. So that's another benefit of this. And there's a few other things that you can do with this material function, including offsetting it to fix like clipping plane issues and things like that. But we are going to set up the basic version of it in the project we made yesterday. So see, we got the melee working, but here we got this problem. See, the weapon and the hands clip into the project. So I'm going to just review the material function, all the steps. So the first is the screen space offset. You're going to need a material parameter collection, and the way you make that, you just right click under materials. This is the material function, and then the material parameter collection is right there. If you open up the material parameter collection, we're going to need 4 parameters. These 3 you could probably make as a vector, but it's typically you only use the Z anyway, so I often make them separately. FOV screen space offset, you'll just leave these as 0 by default. FOV weapon, this is the one you can dynamically set. So the way you set that is you make a material parameter collection function, or not a function, parameter here, and then from this you can actually set it within Blueprints with this set scalar parameter value, and then you can put in whatever. So let's say you always wanted to set it to whatever the camera's field of view is, you would just like put that and then connect that to begin play. I'm going to leave this separate so I can kind of dynamically adjust it so you can see how it works. But these here, you're going to want to make a float. You're going to transform this vector. This you just look up by transform right there and make sure it's set to the correct ones. I am using reroute nodes since this actually gets used a few different times. So the way you do that is you just do named reroute. You can name this whatever you want, and then the way you can just search for it like that, and you can call whatever you output in a material. Transform. That's what you search for. This is another tricky one. Is this one you search for world position. You want the camera relative world position, but it is in a drop down right here. So the one we want is the including material shaders right there. and that's the drop down. But you search for it by getting to world position, and then you use that there. So you set up this screen space offset. You add these together, dot subtract the weapon field of view. This is where your parameter collection will be. So I don't think it's dynamic. It's one second, collection parameter right there. And then you just either get it from the drop down and then you select it by name. Once you save those within your parameter right here and you save this, you should see them in the drop down. You're going to want to divide this by the field of view node, which is a built-in one, FOV right there. You can just search for it by that. You want to -1, which inverts it. I created a reroute node for that. We're combining this. We're combining the camera vector projection, which is this and this. We're multiplying. We're getting the screen space offset, which remember was this back here. And we're adding these together, and then we're also finally adding in the camera position. And this is the camera data, which we'll use a few places. We want to get the near clipping plane. We'll normalize it. Camera direction vector dot divide multiply. This is kind of the magic here, is we want the clip plane. This is going to, if you click custom, you get a little custom node, and then you can paste in this code. This is the one part that's probably the most confusing. And then you want that to be a 1, and you can give it whatever description you want. So like this. Let's actually, is what you search for is custom. The final thing is you're going to want to flatten it. So grab the camera data, grab the clipping data, subtract them, camera direction vector dot, oh, this is also so a bit of code that you're going to need. You're going to need to return this, and this will be plus. So this is also, let's magic, just like this, and then this will be custom. This is the piece of code, and this is going to be a float 1. We'll use the scene depth here. That was for testing. Max multiply. We want to get the clip data again, and then the relative world position, which remember we can get by searching world position. Just like that. Okay, so this is where we output it. And then I just want to go over that. And then to actually implement it in the gun material, they actually use parameter collection. So you want to break it and then make it, but normally you just drop it right into world position offset. So if we press play, things look normal, but when I get close, see the gun is still on top. The hands still clip. And then let me show you, if I go to the parameter collection, I can change the field of view to whatever we want. So if we want it to be 77 or 90, basically anything. And then let's implement it in here real quick. So this is the material that's used for the hands. So we'll put that right in there. Save this material, apply, and then notice both the hands and the weapon are in front despite them clipping through the wall. It's really quite simple to implement once you have the actual function set up. The function itself is involves a bit of custom code in these nodes right here, but it's not a ton of code, and it adds a ton of functionality. It's quite easy to implement into any material you want, and it is pretty easy to customize if you want to implement it. Okay. This video, I just didn't want it to be too long. Mostly, it's just a thing that took me a while to track down myself, so I want to make sure to get the information out there. It's not as hard as I thought it would be to implement, so I hope this helps.